Hello everyone, myself Professor Chavan. We have started the second chapter from our 11th Science CBSE board. Today we are moving towards the next topic from the second chapter, that is the dimensional analysis. Okay. So dimensional analysis, what it says, what it expresses is a very important one, because from the dimensional analysis we can get the idea about the any physical quantity, what will be the cause of that physical quantity due to which that physical quantity exists. About these all the aspect we will get the idea from the dimensional analysis. So it is the one characteristics of any physical quantity which can provide us the knowledge about its causes. Okay, it expresses its cause of that particular quantity. We know that one physical quantity may be depend on the two or more than two fundamental quantities. Okay, we have studied there are 7 plus 2 fundamental quantities, and out of that it may be possible that the any one physical quantity which is existing, that physical quantity may depend on one or more than one fundamental quantities. Okay, as we know the area, okay, how we are giving the area is equal to length into width. Okay, so if we want to calculate the area of a rectangle, then we say that it is the length into width. But what the width actually, what is the basic behind this width? It is nothing but the length. Okay, it is again the length into length. Okay, so we can say here that the area is having the two dimensions. Okay, it is having the two dimensions. Okay, here two dimensions of which of length. Okay, two dimensions of length. Like this we can go for the another physical quantity like the volume. Okay, volume of a square is equal to length into width into height. Okay, length into width into height. But what is the basic quantity behind that particular width and the height? It is nothing but the length. So length into length into length. So the volume depends on the three dimensions. The volume is a three-dimensional quantity. Okay, three-dimensional quantity of length. So here we have seen the area and volume are the two physical quantities which are depending on the one basic fundamental quantity, that is the length. But there are also some quantities which depends on more than one fundamental quantity. Like if we think about the density. Okay, how the density is given? Density is equal to mass upon volume. Okay, mass upon volume. So here we can write it as the mass into volume inverse, or we can write it as m into L into L into L. That is, our density is having the one dimension of the mass and the three dimensions of the length. Okay, one dimension of mass and three dimension of length. So any physical quantity, any physical quantity depends upon one or more fundamental quantities. Okay, one or more fundamental quantities, and the dimension expresses the physical quantity in terms of another basic quantities. Okay, so what is the dimensional analysis actually is, we have to express the physical quantity in terms of its fundamental quantities. Okay, so one physical quantity can have the more than the 2 or 3 fundamental quantities. Like we have seen here, for the density we have to go for the mass also and for the volume also. So volume is nothing but the length. Okay, so the density depends upon the 2 fundamental quantities, that is the mass and the volume. Okay, mass and the volume, and we express the density in terms of the mass and the volume also. Here the 1 dimension of the mass and the 3 dimensions of the length. So what is the dimensional analysis? What is the dimensions? Dimensions is the characteristics of any physical quantity which expresses it into its basic quantity and its multiples. Okay, the dimensions expresses the any physical quantity into its basic quantities and its multiples. So that is the dimensions, and we have to analyze these dimensions which are given in our physics. Okay, so for that purpose we have to go for the dimension formula. What is the dimension formula? How we can prove or how we can write the dimension formula? Here we express the mass into length into length into length. So instead of that we have to write it in terms of its power, like the mass into L cube. Okay, so any physical quantity is expressed in terms of the 3 basic fundamental quantities, and those are the mass, length and time. Okay, we have seen in the CGS system, in the MK system or in SI system, the 3 basic quantities are considered mainly, that is the mass, length and the time. Okay, so on that basis we have to express our physical quantities in terms of our mass, length and time, even if those quantities are not present in that. Like if we think about the velocity, then in case of the velocity, there just we have to think about the, what is the formula of velocity? Velocity is nothing but the distance upon time. So in that case we have to go for the length and the time, but we have to express the velocity in terms of the mass, length and time. So for that purpose we have to write its dimensional formula. So we'll see the dimensional formula now. How the dimension formula is written? There is one dimension analysis, in that the dimensional formula. How we can write the dimensional formula? So for writing the dimensional formula we have to one steps. First of all we have to write down the physical quantity. Okay, for which quantity we have to express the dimensional formula. Then we have to go for the physical formula. Then we go for the dimensional formula. Then it's units. Okay, so any quantity we take, we have to first of all go for its physical definition, and on that basis we have to go for its physical formula, and on that basis we can go directly for the dimensional formula and we can write its unit. Okay, so let us see the example of the area. Suppose the first we take the area, then how the area is given? The area is given as the physical formula as the length into length. Okay, is the length into width. Okay, then to express this in case of the dimensions, we write it as the length into length. Then to express in terms of the mass, length and time, we have to write it as MLT. Now in this case, is there any mass? No. Okay, so we have to write here as a 0. Then is there any length? So 2 lengths we are using here, so we will write here as the 2. Then is there any time? No. Okay, so we will write it as the t raised to 0. So what is the dimensional formula for the area? It is m raised to 0, l raised to 2 and t raised to 0. Now what is the unit of the area? It is meter square. Okay, meter square. Now if we go for the volume, then second volume, it is given as the length into width into height. Okay, so we can write down it as the length into length into length. Okay, this is in terms of the dimensions. Okay, this is in terms of the multiples of the dimensions, because what is the basic behind the width and the height? It is nothing but the length. So we have to write its dimensional formula. So for that purpose we have to think about the m, l and t. Now similarly, as per the previous process, we have to go here like the area. Okay, so is there any mass? No. So we have to write here as the m raised to 0. And is there any length? Yes, 3 times length. So we have to write here 3. Is there any time? No. So we can write here as the 0. Now what is the formula? It is m cube. Unit is the m cube. Okay, unit is the m cube. Now we'll go for the density. Now in the density, how we are expressing the density? It is nothing but the mass upon volume, or we can write it as mass into volume inverse. Okay, so here we can express it as mass into length is to minus 3. Okay, because we have to take the inverse of the length. So as per this dimensional formula, we can write down the dimensional formula in terms of the mass, length and time. So here the mass is 1. Now the length is minus 3, and here the time is 0 again. So the formula is mass or the kg per meter cube. Okay, what is the dimensional formula for the density? Is m raised to 1, l raised to 3, t raised to 0, because time is not available there. Okay, time is not available there. So our units are kg per meter cube. Similarly, if we go for the velocity, we will see for the velocity, how the velocity is given? The physical formula is distance upon time. So we can write down it as distance is nothing but the, what is the basic quantity behind the distance? It is the length. So we can write it down as the length upon time. That is, we can write here in terms of the m raised to 1, because m raised to 0, because mass is not present here. So m raised to 0, l raised to 1, because length is present, and time is, we have to take the minus 1. Okay, m raised to 0, l raised to 1, t raised to minus 1. And what is the formula here? It is meter per second. It is meter per second. Now if we go for the acceleration. Okay. How the acceleration is given? It is given as the velocity upon time. As we know, the velocity is expressed in the length upon time. So we can write it as the length upon time. Okay, length upon time. That is length upon time square. Okay, so you can write it as here in terms of the dimensional formula, the m raised to 0, l raised to 1, and t raised to minus 2, and its unit is meter per second square. Okay, understand why it is the meter per second square, or we can write it as meter second raised to minus 2. Okay, here we also can write it as meter second raised to minus 2, because here is the minus 2. And in terms of the velocity also, you can write it as meter second raised to minus 1. Okay, meter second raised to minus 1. Now, if we go for the force, so what is the formula of the force? Force is equal to, what is the definition of a force? Force is nothing but the mass applied to the acceleration. Okay, that is the force. Okay, so F is equal to, force is equal to, we know what is the definition of the force. It is equal to mass into acceleration. So now in this case, we can write down the dimensional formula as the mass into length upon times raised to minus time raised to 2. So here we can write down the dimensional formula as m raised to 1, l raised to 1, t raised to minus 2. And what is the formula of the force? From this dimensional formula, we can write down as the kg meter second raised to minus 2. Okay, kg meter second raised to minus 2. Okay, so here in case of the force, we have seen that the force depends upon the acceleration and the acceleration depends upon the velocity, but the velocity is also depends upon the distance upon the time. Okay, so we can say that the force is indirectly depends upon the velocity. Okay, force indirectly depends upon the velocity. Now, what is the purpose of the dimensional formula? Or likewise, these are the some basic dimensional formulas which we have to remember for the further physical quantities like the work, energy, momentum. Okay, so for that physical quantities, we may require this some basic dimensional formulas so that we can write them down directly there for any further calculations, because these are the basic quantities. These are the some basic quantities which we require for the any calculations like the work, energy, momentum, surface tension. Okay, so for the calculation of those quantities, fundamental quantities, we require this knowledge of this basic quantity. So we have to remember these 6-7 dimensional formulas directly so that we can put them down there. So this is about the dimensional formulas. Now, what is the purpose of using the dimensional formula? Why it is important to know the dimensional formula? Okay, so from the dimensional formula, we can get the idea about the basic fundamental quantities on which any physical quantity depends. Okay, it tells us about the fundamental quantities on which that physical quantity depends. Then the second one is it can predict on which fundamental quantity, that's particular physical quantity, more depends. By looking at the physical quantity like this physical formula, we can't predict about on which quantity that particular physical quantity depends more. But from the dimensional formula, you can get the idea about the quantities on which this force or this physical quantity depends, because it directly tells you that m raised to 1, l raised to 1, t raised to minus 2, or the dimensional formula mass into length upon time square. So it can tell us about on which quantity or to the which quantities this physical quantity directly proportional, or it can tell us about on to the which fundamental quantities this existing physical quantity is inversely proportional. Then it can also tell us about on which fundamental quantity this physical quantities directly depends. Suppose we have to increase the force, then what we have to do? From this dimensional formula, you can tell me if we have to increase the force, then what we have to do? We have to increase the mass, we have to increase the length, but we have to reduce the time. Okay, we have to reduce the time. So when we reduce the time, the quantity of force increases. Or we can say that if we require to reduce the time for any application of the force, then what we have to do? We have to increase the force, but how much amount? Here you can see that the force is inversely proportional to t square. Okay, inversely proportional to t square. Then if we want to increase the force, then to reduce the time, what we have to do? We have to increase this force by 3 times. Okay, we have to increase this force by 3 times. Suppose we have to reduce the time period of 30 seconds into 10 minutes, then what we have to do? We have to increase the force by 3 times. Okay, we have to increase the force by 3 times. So like this, we can say that on which physical quantity, on which fundamental quantity this physical quantity depends, or it will directly tells us that how much it depends. Here is the square, so in multiple of this we have to increase or decrease the force. Okay, if we reduce the time, if we have to reduce the time, then we have to increase the force, but by how much percentage or by how much multiple? By 3 times more or the 6 times more. Okay, when we have to reduce this time, then we have to increase the force in multiple of that, because the force is inversely proportional to the time square. Remember, here the square is here, so accordingly you have to increase the force to reduce any time period. So the dimensional formula helps us to remember such a increase or decrease in that respective quantities. Okay, if we have to increase the time, then we have to decrease the force, but by how much amount? By in that proportion. So here is the square, so in that proportion we have to increase or decrease the dimensional formula. So the area, volume, then density, velocity, acceleration, force, these are some basic dimensional formulas which we have to remember. On that basis we can go for the further physical quantities like the work, energy, surface tension. Okay, we have to use these formulas there. Let us write down the uses of the dimensional formula. Okay, there are 3 uses of the dimensional formula that, as we have explained, it tells us about the involvement of the basic quantities in that particular physical quantity. Okay, uses involvement of basic quantities in any physical quantity. Okay. We can find out what is the involvement of any physical quantity into that particular physical quantity. Like we have seen the force, in that there are mass also involved, then the length also involved, and the time also involved. Like the density, there the mass also involved and the length also involved. So it tells us about the which basic quantities are involved in that particular physical quantities. Then the second one is which quantity is directly proportional and which quantity is inversely proportional. Okay, it tells us about the different physical quantities which are depending on another basic physical quantity or the fundamental quantities. So it tells us about by changing the which quantities, the how much effect will be there, because we'll get the relation between the physical quantities there, how that physical quantity is related to another basic quantity, and to increase that particular quantity, which basic quantity we have to increase, or to increase that particular quantity, which basic quantity we have to decrease. So like that way, that information can we get from the dimensional formula. Okay, so the third one, it gives the effectiveness of basic quantities on that physical quantity. By seeing the power. Okay. By looking at the power, we can get the idea about which quantity will affect more that particular physical quantity, because if there is the inversely proportional, then we get the power as the negative, and if there is the directly proportional, then we have to write the powers in terms of the positive powers. Then if any physical quantity depends on the next fundamental quantity, then we can get the idea which is more effective. Or if we have to increase the force, suppose we take the example of a force, then force is mass into length upon time square. Okay, so in this, if we have to increase the force, what we can do, we can decrease the time, or we can increase the mass. Okay, we can decrease the time or increase the mass, then we can get the more amount of force there. Or if we have to reduce the force, then what we have to do, we have to increase the time. Or if we have to increase the force, what we have to do, we have to reduce the time, because the time raised to 2 gives us the idea about this. By looking at the powers, we will get m raised to 1, l raised to 1, t raised to minus 2. That is, which is more effective? Which is more effective than the mass and the length? The time is more effective, because the time is having the more power. Even if we increase the mass, how much amount of force we get? That is not higher as compared to if we decrease the time, because the time is having the more power. The time is more effective in the case of the force because the time has the more power. Okay, so to increase the any force we have to decrease the time, then we'll get the more force. So out of these three basic fundamental quantities we will get the idea about which quantity is more effective, and here we get the time. So likewise there are the other physical quantities also which are directly or inversely proportional. Now even the directly or inversely proportional is there, we have to look at their power so that we will get the idea of their effectiveness about this particular forces. Okay, so that's why these are the some important uses of the dimensional formula. Now in the next lecture we will see about its applications.